learning, we have already studied many types of the equations. Okay. So now we will study about the oxidation and the reduction and the redox reactions. Okay. Yeah. We'll first study about the oxidation reaction. Write down this oxidation. The reaction in which oxygen is added. Oxygen is added to the reactant is called oxidation reaction. Is called oxidation reaction. Okay. And the reaction in which hydrogen is removed, from the reactant is also called as oxidation reaction. It is also called as an oxidation reaction. Okay. Example, copper plus oxygen. You will get copper oxide. It is a black powder. Okay. To balance, we can balance like this. Okay. So copper symbol is what? Cu. When copper is combined with the oxygen, we get copper oxide. Okay. Copper oxide is a black powder. Copper oxide is a black powder. So here copper combines with the oxygen. So oxygen is added to the copper. So it is called as an oxidation reaction. Copper is added here. That's why it is called as an oxidation reaction. If you remove the hydrogen in any reaction, if you are removing the hydrogen also, we call it as an oxidation reaction. Either adding the oxygen or removing the hydrogen from any reactant, then we call it as an oxidation reaction. Next comes a reduction reaction. So the reaction in which oxygen is removed from the reactant, or hydrogen is added to the reactant is called reduction reaction. We call it as a reduction reaction. Okay, we call it as a reduction reaction. So example, copper oxide plus hydrogen, we get copper plus the water. Okay. So here copper oxide contains the oxygen. So in copper oxide, oxygen is removed. So we call it as a reduction reaction. But most of the reaction will be redox reactions. Redox reaction means there will be reduction as well as oxidation. Redox reaction means there will be reduction as well as oxidation. Both will be there. So that we call it as a redox reaction. Many reactions will be actually redox reaction. That is, if oxygen is removed from one reactant, what happens to that? It will be added somewhere to the other reactant. Then there is oxidation as well as reduction both. Then we call it as a reduction reaction. For example, here copper oxide is there. Oxygen is removed from copper oxide. Oxygen is removed from the copper oxide and it is added to the hydrogen here. So copper oxide here, there is reduction, right? Reduction here, as well as oxygen is added to the hydrogen. So there is oxidation as well as reduction. Both are present in that. Many reactions will be actually redox reaction. Redox means both oxidation and reduction. Both will be there in the reaction. Then we call it as a redox reaction. So here actually we can call this as a redox reaction because oxidation is there of the hydrogen, it is oxidized, whereas the copper oxide, it is reduced. So both are there, we call it as redox reactions. Okay, here in the book also they have given reduction example because copper oxide is reduced. To show that, they have given this example. Okay. A reaction in which oxidation and reduction, reaction in which oxidation and reduction takes place is called redox reaction. Example, copper oxide plus hydrogen will get copper plus water. Copper oxide is reduced to copper. Copper oxide is reduced to copper. Hydrogen is oxidized to water. Hydrogen is a reducing agent. It is a reducing agent. Copper oxide is a oxidizing agent. It is an oxidizing agent. Copper oxide is a oxidizing agent. Okay, in exam they ask like which is a reducing agent or which is oxidized, reduced, all this. So here copper oxide is reduced, not the copper. You should not write copper is reduced. What is reducing here? The copper oxide is reducing. Okay, and what do you mean by reducing agent? Reducing agent means which is the one which is a reason to reduce, or which is the one which is taking the oxygen. That is the reducing agent. So hydrogen is the reducing agent and copper oxide is the one which is giving the oxygen. So that is called as an oxidizing agent. Okay, that is called as an oxidizing agent. Then write down some more example of redox reaction. Zinc oxide plus carbon. Zinc oxide plus carbon. Okay, you will get zinc plus carbon monoxide. Carbon monoxide. Okay. So this is the one when it is used for refining the metal. Metal is obtained from the ore, right? Metal is obtained from the ore, right? There, metal will be in the form of oxides, sulfides, something like that. So zinc oxide is reduced to the metal by this process. Okay, zinc oxide zinc oxide is reduced to the metal by the carbon, because carbon is a good reducing agent. Okay, so zinc oxide plus carbon, you will get zinc plus carbon monoxide. When you have CO2, what we call it as? We call it as a carbon dioxide. Here it is carbon monoxide. Okay. Next, we'll study about the corrosion. Next, we'll study about the corrosion. Corrosion. Corrosion is a process. Corrosion, it's a process which produces unwanted substance. Example, iron gets rusted. When iron is left for many days, right? When iron is left for many days, and when it is exposed to the atmosphere, when iron is exposed to the atmosphere in the presence of moisture, we get iron oxide, correct? When iron is exposed to the moisture and the atmosphere, what happens? For a longer time, then it is converted into iron oxide. It is a reddish powder what we get, but it is unwanted. Actually, the iron, we lose the iron right there, so that cannot be used. Even gates will be rusted, iron bridges will be rusted, like that. That is the unwanted substance actually. So corrosion, from the corrosion, actually the iron metal, it will become weak. It becomes the powder there, correct? It becomes the powder, so which cannot be used, like that. So the gate will be rusted or bridges will be there. So corrosion, it produces unwanted substance. Even silver get rusted, right? Silver corrosion will be there even in the silver, even in the copper. Silver, it reacts with hydrogen sulfide. Silver, it does not react with water, moisture, carbon dioxide or oxygen, but it reacts with hydrogen sulfide. Okay, and it forms silver sulfide. Okay, it reacts with the hydrogen sulfide. Silver reacts with the hydrogen sulfide. It reacts with the hydrogen sulfide to form silver sulfide, to form the silver sulfide. It is a black color coating. It is a black coating. It is a black coating. in home and all we use for puja and all, right? Silver plates. If you observe, if you leave it for many days, what happens? A thin layer of black coating will be seen. Correct? A thin layer of black coating will be seen on the silver articles. That is not because of oxygen, because it does not react with the water or oxygen, but it reacts with the hydrogen sulfide which is present in the atmosphere. So it will form the silver sulfide, which is a black coating. And we observe that it will be a very thin coating, right? Even though you leave it for longer time also, only a thin coating will be formed of that. What is the reason? Because that thin coating which has formed, it acts as a protective layer and helps avoiding the further corrosion. Again, I repeat, silver sulfide, what it has formed, a thin layer of silver sulfide will be formed, which is a corrosion. Okay, but it becomes a protective layer. Because of that, further corrosion will not happen. Because of that, further corrosion will not happen. See, if you leave the gate, iron gate for a longer time without painting, what happens? It starts like rust will be there, and we see the powder. And if you leave for a longer time, even the whole gate can get rusted. But silver and all, it is not like that. Just a thin layer will be formed. After that, that acts like a protective layer. Because of that, further corrosion will not happen. Okay, so this is one of the advantages. That is why we use. That is the reason we are using the silver. If it even rust completely, means like iron, we cannot use the silver. And that is the reason it is costlier also. One of the reason is that, because it forms a protective layer. Okay, and even the gold we see, it will not rust at all, or it will not corrode at all. Even in sulfur or water, even in the steam, it will not corrode at all. It will not, it loses its property. Correct? Gold will not loses its property, hence it is valuable in nature. That is also one of the reason why it is very valuable. Okay, what about the copper? Can you tell? Will it corrode copper? Huh. What happens? Which color is green? Green. Copper forms a green coating. Copper will form a green coating. Okay. So, and even that green coating is actually poisonous in nature. Green coating, what we have, no, that is poisonous in nature. That's why if you are using the copper vessels, you should be careful. That is, you should be careful that it will not get corroded. It's good to use the copper vessels, but you should make sure that it will not get corroded. Okay, so that is a green coating what we see. Write down that copper corrode, copper corrode, and a green coating is formed. A green coating is formed. It's formed. Next, how we can prevent the corrosion? How we can prevent the corrosion?
By painting and greasing.
By painting, greasing, yeah. Galvanization. What do you mean by galvanization?
Electroplating one material.
Other. Zinc is plated on the iron. Electroplating of the iron by the zinc. A thin layer of zinc is coated on the iron, then we call it as a galvanization. Okay, even that helps in the prevention of the rust, or the preventing from the corrosion. Okay, and what else, what other methods we can use? Painting, greasing, galvanization. Mainly here, it should not be exposed to the atmosphere. The
Moisture.
Yeah, it should not be exposed to the moisture. In or the atmospheric air. So then it will be not corroded. So because of that only we do the painting, greasing, galvanization, all this process. Okay. Next comes the rancidity. Rancidity. So what do you mean by rancidity?
Oxidization of fat.
Oxidization of the fat, we call it as rancidity. So when fats and oils they are oxidized, what happens? There will be some taste will change. The taste of the food will change, and also the smell of the food will change. So that we call it as this process. We call it as the rancidity. And how we can prevent that? It can be prevented by packing the food by packing the food airtight packs we can use, and nitrogen will be filled in the packet. Whenever nitrogen is filled in the packet, so it will avoid the rancidity. Actually, lays, chips and all, it will be filled with the nitrogen, right? The packet will be filled with the nitrogen. Because of that, we can see that it will be not rancid, correct? The smell will not be changed. What is the reason? Because it is filled with the nitrogen gas. Okay, it is filled with the nitrogen gas. Write down that. The process in which fats and oil are oxidized is called rancidity. It is called as a rancidity. The taste and smell of the food changes due to the rancidity. Where we can see this, when the fried foods, if you leave it for 1 week like that, exposed to the atmosphere and leave it for 1 week or more than 1 week, what happens? We observe that the food, it would have lost its crispiness, and the taste of the food will be changed. Even there will be some smell will be there. Okay, so that is the reason the fried foods we keep it in a airtight container, or the container is filled with the nitrogen gas, so that there will be no rancidity of the food. Okay, there will be no rancidity of the food. So prevention by the rancidity. Food is kept in the airtight containers. The container is filled with the it is filled with the nitrogen gas, so that food does not get rancid. Does not get rancid. The other one method is what? You can add antioxidants. You can add antioxidants or add it to the food. When you add antioxidants, it does not get rancid. Okay. So this completes this chapter. So the exercise part is there. Okay. We let us do few balancing of equations, and then we will continue. Okay. Balance the equations. Balance this equation PbNO3 twice. When you heat it, we get PbO plus nitrogen dioxide plus the oxygen. Balance this equation. Lead nitrate. When you heat the lead nitrate, okay, we get lead oxide plus nitrogen dioxide plus the oxygen. Listen here, everyone. Okay. We have lead in the reactant. We have lead, nitrogen, and oxygen. Okay. We have lead, nitrogen, and oxygen. In the product also we have lead, nitrogen, oxygen. Okay. So one lead is there, correct? Nitrate group. See, it is like that. One lead is there, and you have two nitrate group. Okay, you have two nitrate group. That's why they have written two here. It is like this. Listen, everyone. Huh? Lead. It is with two nitrate group like this. If you count nitrogen, how many is there? 1 plus 1, 2. Oxygen 3 plus 3, 6. So here also you have one lead, nitrogen 2 is there, and oxygen 6. 3 into 2, 6. Okay. Here you have one lead, nitrogen 1, oxygen how many are there? 2 plus 2, 4, 4 plus 1, 5 is there. Now, nitrogen, here it is 2, here it is 1, correct? So, what we have to make it, you can make this as 2NO2. So, PbNO3 twice. We can write it as PbO plus 2NO2 plus O2. Okay. So, here I have not changed anything in the reactant. So, it will be 1, 2, 6. Here, PbO lead it is 1, nitrogen 2 here. 2 NO2 means NO2 group 2 are there. That is the meaning. Okay. So, 2 nitrogen is there. What about oxygen? 2 plus 2, 4. 4 plus 2, 6. 6 plus 1, 7. Okay. Still, oxygen here, it's an even number. You have an odd number. Whenever you have like that, so try to make this as an even number. Okay. Always try to make that as an even number. How you can make as an even number? I have to add 2 here. 2 PbO. So, what we will get here? Pb NO3 twice. We get 2 PbO plus 2 NO2 plus O2. Okay, so we have not changed anything in the reactant, so it will be 1 to 6 itself. Here 2 lead is there, nitrogen 2 is there. Okay, 2 is there, oxygen 2 2s are 4, 4 plus 2 6, 6 plus 2 8 is there. If you observe, when we try to make it as an even number, nitrogen here it is 2. Okay. Yeah, nitrogen here it is 2. This is also 2. But lead has changed. Here it is 1, here it is 2. Correct? So how I can increase the lead? I have to make it 2 times. And you cannot change like Pb2. Okay, you cannot change the formula. So what you can do is 2 times PbNO3 twice. You have to make it like that. So you will get it as 2 times PbNO3 twice. You will get 2 PbO plus 2 NO2 plus O2 you will get. Okay. So here 2 PbNO3 twice means PbNO3 twice. Like that you have 2 molecule. Okay, 2 molecule. So now you have 2 lead here, correct? 2 lead, nitrogen here 2. 2 plus 2, 4. And how many oxygen is there? 3 twos are 6. 6 plus 6, 12 is there. And here 2 lead is there. Nitrogen here 2. So to make it 4, what else I can do? I can make this also as 4. Okay. So lead 2, nitrogen will be 4. And what about oxygen? 4 twos are 8. 8 plus 2, 6. 8 plus 2, 10. 10 plus 2, 12. Now it is balanced. Always remember, whenever odd number is there, you cannot balance one even or odd. You have to make the one which is odd as even, then you have to continue. Okay, understood? No, write down. And when you increase, there will be again imbalance will be there. See here, lead changed. So what you can do, you can add wherever it is again less and try to balance. Correct, no?